In this video, we'll be looking at the change of base formula. Now, this particular formula and/or rule is drastically different than the previous rules we looked at for logarithmic expressions, specifically because the product rule, the power rule, and the quotient rule don't affect the base of the log. This one, however, gives us the opportunity to manipulate the base. So, for any log functions where we have, say, log base b of m, and we want to change the base of this log to, say, a more appropriate base. I'm going to go ahead and use a for the generic case, but in most examples that we're going to look at moving forward, are going to be base 10 or base e, because those are the log functions that we generally use. So this is going to change to a log base of a. Now, the way that the formula works is that both the numerator and the denominator log now get that new base. The difference, however, is what goes inside the new log functions. What's inside the original log will go inside the top log function, and what's the old base will now go to the inside of the bottom function. So this is the change of base formula. This allows us to manipulate a log function that has a base that we don't like into another log function that has a more appropriate base for us to work with. So let's just say, for instance, that I'm going to go ahead and convert this log base b of m into either a natural log base. Again, natural log base, remember, is simply base e. That's going to be ln divided by ln. The inside stuff goes on top. The old base goes on the bottom. And again, that's natural log of m divided by the natural log of b. And then lastly, if I'm going to go ahead and use the common log, it's log base b of m is equal to log without a base divided by log without a base, such that the inside on the top is m and the inside on the bottom is b. So now if I'm going to go ahead and do an example with this, we would say we want to use, we're going to go ahead and use natural logs. Let's do natural logs to evaluate. Okay, the following expression. So the following expression is log base 7 of 2,506. Now, you'll notice here that I can't actually evaluate log base 7 of 2,506. Can't be done. It actually, don't know how to do it in the calculator unless you have a specialized button in the calculator that allows you to plug in bases. We have to convert this appropriately to a different base. So we're going to convert this to the natural log base, and inside the top is going to be 2,506, and inside the bottom here is actually going to go ahead and be your original base of 7. So now I have natural log of 2,506 divided by natural log of 7, and this is something that I can actually type into a calculator, whereas before I couldn't. So in my calculator here, I have a natural log button under the second button. For yours, it might be in a different location, but there's ln right there, so I'm going to go ahead and hit second ln, and I want 2,506, and I want to end my parenthesis, making sure that the natural log function there stops, and I want to divide it by, again, the natural log of 7. This is going to provide me with, I'm going to have to hit alpha equals, otherwise it's not going to approximate. It's going to evaluate this to approximately 4.02, let's do 2. So that is how we're going to be able to evaluate log functions when we don't actually have the base in something that we can easily use. Again, we can convert this to the common log base, being log base 10 of 2,506 divided by log base 10 of 7. But it's not necessary for us to convert it to that unless it tells us to. And it's not really helpful for us unless we're going to use this in the calculator to evaluate it. So that's how we use the change of base formula to manipulate and simplify expressions.